So we have a scientist who's studying bees, and he's also studying wasps on an island. And the number of bees measured in thousands, naturally, is modeled by this equation, which is 45 plus 220, and it's an exponential equation, where t is the number of years from the start of the study. Now, all we need to do is find the number of bees at the start of the study. At the start of the study means that we're looking at time is equal to 0. So we just substitute time 0, and the 0 is in the power, so that will make it e to the power of 0, and you should know that that will be equal to 1. And so the number of bees will be just 45 plus 220 times 1, which is 220, and that makes it 265,000, because the number of bees is measured in thousands. And so this is where you'll get your mark. To get your next 3 marks, you need to show that exactly 10 years after the start of the study, the number of bees was increasing at a rate of approximately 18,000 per year. The most important part over here is to show that it is increasing at the rate. Now, not often will they make the word rate here bold, but this is the most important information that you're getting over here, because once you get the word rate, you know you need to differentiate our original expression, which is the number of bees. So to differentiate this expression, we need to write dn over time, dt, and we ignore the 45 because we can't differentiate that, but we will differentiate the exponential, so we'll need to write down 0.05, and then we just leave the whole expression once again, so it's 220 e to the 0.05 t. When you multiply the 0.005 by 220, you will get 11 e 0.05 t, and this is the rate. So now we want to show that the rate is 18,000 per year after 10 years. So let's see if it is actually 18,000. We're going to insert into our rate t for 10 and work this out. This will equal to something like 18.1359, and we're not exactly told. In terms of thousands, we're talking about around 18,000. So we do not really need to count 0.1 of a bee. So it's just 18,000 with 3 zeros. And for the last part, which is also 4 marks, we are given the number of wasps now by this equation that we're going to model, where t is the number of years from the start of the study. Now, when t is capital T, some t, according to the model, there's an equal number of bees and wasps. And we're to find that capital T to 2 decimal places. That means we need to equate the 2 equations and find what the capital T is. So when we put the 2 functions, when we equal them at that intersection, we will find the answer to our equal number of bees and wasps. Let's substitute the capital T into both of these equations. My first thought would be to put the e's on one side, but then I noticed that what I have here is a negative, and so that is slightly different. Let me rearrange it. So a negative exponent will have to go down into the denominator. My inclination is to move everything to the left. Now I can multiply this denominator over here through each of the terms. I'm hoping that you can see that this is a quadratic where e, okay, would be like x. So that this is 35 e to the 0.05t, and then we add 220 e to the 0.05t, and this e will be all squared, minus 800 equals to 0. I'll rewrite this one more time because this should go, 220 e to the 0.05t, and that should be squared, plus 35 e to the 0.05t, and now we finish off that because that's the way a quadratic would look like. You will get a mark for that, even though you could divide everything by 5. You will get a mark for either this or that. At this stage, you are allowed to use a calculator for solving this quadratic, but it does say at the start of the paper that answers without working may not gain full credit. So you really had to go through all this to get to the quadratic. You can't just equate the two equations and use a calculator to solve it. Now, using the calculator, you'll just go to equation and polynomial with degree 2, where a now becomes 44 or 220, b is going to be 7, and c is equal to minus 160. There will be two answers because it's a quadratic, and e 0.05t is equal to, on your calculator, something like 1829038. The second answer will be negative, and we cannot have a negative e, so we will just use this answer. Now we're going to get rid of e, so we have to use the natural log, and that will become ln, and so t is equal to ln 1.829 divided by 0.05. And we wanted two decimal places, so t is going to be 12.08. I hope you found that useful, and if you want to have a look at other videos similar to this, then please look into my channel and have a look. There are a number of playlists. You may want to have a look at the rate of change playlist, and also subscribe so that you can get notification of further videos that I'll be making, and this really helps me a lot. And also, if you could like it with the thumbs up. Thank you.